So here we have a question in which a particle is sliding down the smooth sloping face of a wedge. But the interesting thing is that the wedge itself is sitting on a smooth horizontal surface. And the question asks us to find the acceleration of the wedge due to the block or the particle sliding down it. Let's work out, or let's draw the forces acting on the particle that is sliding down the wedge. The first force I'm going to draw is the normal force from the wedge acting on the particle. The particle also has a weight m, well, I'm going to call it m1, a weight m1g. Now let's think about the forces acting on the wedge. The wedge has the equal and opposite normal force acting on it. It has the weight of the wedge. I'm going to call the mass of the wedge m2. And there will be a reaction force from the surface that the wedge is sitting on, acting on the block, on the wedge, and I'm going to call that R. Now, just to keep things nice and analytic, let's call this angle here theta. And let's draw some lines to help us think. So that's a vertical. That's the carrying on of the line of action. Now, since this is a right angle, that makes this angle here 90 minus theta, which makes this angle here theta, which means that that angle here is also theta. Let's draw a line of action here like this. Now, this makes this angle here theta, as it's parallel to n, which means that that is also theta. So we've drawn on the forces acting on the wedge and the forces acting on the block and some angles. Now we've drawn all the forces. The next thing to do, of course, is to draw on the accelerations. And now this is where I'm going to use a non-inertial frame to solve this. I'm going to jump into a non-inertial frame that is actually accelerating with the wedge, because it turns out this makes the mathematics a little bit easier to solve. So here's my system, and I'm going to jump into a frame of reference that is accelerating to the left with a rate a. So it's accelerating to the left a, which is the same acceleration as the wedge. This means I'm going to have some pseudo forces in my non-inertial frame of reference. Now the pseudo forces have the size ma and act in the opposite direction to the accelerating frame of reference. So for example, on my particle, I will have a pseudo force m1a acting in this direction, and on my block, my wedge, I will have a force m2a. So they are my two pseudo forces. In this frame of reference, this non-inertial frame of reference, my particle will appear to accelerate just simply down the plane. So here is the acceleration down the plane of the wedge. Let's say the acceleration is f, as seen from my non-inertial frame that itself is accelerating at a to the left. So now I've put all the real forces in, and I've jumped into a non-inertial frame of reference, and I've therefore added the pseudo forces. Now I can just use Newton's laws as per usual. Let's call the particle system 1 and the wedge system 2. And then we can resolve for system 1 and resolve for system 2. So, resolving parallel to the normal force acting on 1, and we'll do this for object system 1. We have n minus m1g cos theta plus the pseudo-force m1a sine theta must equal the acceleration in the direction of the normal force, and I've deliberately chosen that because F is in the at right angles to n, meaning the acceleration in that direction is 0. I will now look at system 2. So system 2, and I'm going to resolve horizontally. And I do that so that I eliminate R and M2G and only have the A and the N coming into my equations, which makes the maths a bit simpler. So what do we have? We have the pseudo-force M2A minus N sine theta. And in my non-inertial reference frame, the block is in equilibrium, it's not accelerating. So I have my two equations, equation 1 and equation 2. From equation 1, I have that n equals m1g cos theta minus m1a sine theta, which I can then put into equation 2. m2a minus n, which is actually m1g cos theta minus m1a sine theta, and then we have the sine theta must equal 0. So you can see that what I've done is, here is my n, here is my n, and there is my n, and I've used this n to go into here. That's all I've done. So now I can take this new equation and then solve it for A. And if I rearrange this, and I'm careful with my algebra, so if I make A the subject, I get this answer, and then if I put the numbers in, because I know what M1 is, I know what G is, I know what theta is, I know what M2 is, I can find the value (1.06 for A,